Dear viewers, you're most welcome. My name is Mutebi Ibrahim, a student of Aga Khan University, Tanzania, and I'm here to present to you a simple main lecture on how to prove an algebraic expression or identity using the concept of squares. So our objective today, we want to prove an algebraic identity A minus B in bracket squared, which is A squared minus 2BA plus B squared, using the general concept of squares. So, assuming that you have a square of uniform length A, and this square has an area A1, so our square has an area A1. But remember, from the knowledge of squares, we know that area is given by length times width. So our length here is A, and the width is A. So we have A times A, and the expected answer should be A squared as our area, A1. Please take note of this A1 is the area of the original square. So what if we resize this square by a uniform length B on either sides? That means we have cut off one part of the square. This part from here to here is A. And we're also going to cut off this part so that we have a new square. So this is a new square, A2, whose length and area has changed. So initially the length was A, but we have removed one part B. So the left length is A minus B, as you can see it here. So these are the parts we have got from the original square. We have this one as A2. We have another shape here, it's a rectangle, and another shape here, which is a rectangle. So our new square has length A minus B, and the width also A minus B. Then this other shape down here has a length A minus B. Reason being, this length from here to there is the same as from here to that point. That's why we have the same length. Then it has a width B. It's a part we cut off. Then this shape here on the left has a length A because we did not change it, but the width is B, is the smaller part we cut off. And all of them have new areas. This has area A2, as we saw it in the previous part. This has area A3, and this has area A4. So the next part we are going to look at is calculating these areas using our knowledge of length times width. So when we look at area A2, it is length times width, which is A minus B into A minus B. That gives us A minus B squared. We go to area A3, the length is A minus B and the width is B, which gives us BA minus B squared. Then we go to area A4, which would be length A and the width, which is B, and gives us BA. So now our intention is expressing area A2 in terms of the original area of the original square we had, the area of this rectangle at the bottom, and the area of this rectangle on the left. And that would mean that the area A2 will be getting the area of the original square we had, minus the area of this red rectangle we have, minus the area of this blue rectangle. But remember, A1 is A squared, A3 is BA minus B squared, and A4 is BA. When we substitute all these into our equation here, we have something similar to this. A squared minus bracket BA minus B squared, that's for A3, and minus BA for A4. So when you open up our brackets, we have something similar to this, which is A squared minus 2BA plus B squared. 2BA comes from this, we have BA and BA. Those are two parameters. So that when we join them, they give us 2BA. And this turns into a positive, reason being that when you multiply negative times the negative, it becomes a positive. Which proves our identity we had here at the beginning. So A squared, which is the same as A minus B squared, is equivalent to A squared minus 2BA plus B squared. So we have used the knowledge of squares to prove an identity. We can extend the same knowledge to prove other identities, like a squared minus b squared, what we call a difference of the squares. And I'm leaving it to you as your activity to check your understanding. Thank you very much for watching. I hope you enjoyed it.